Okay, let's get started. We ended up on slide 26, so I hear, from lecture number 13. Is this 13? Yeah, this is 13. So we're going to go from 13 to 14 today. I'll talk about risk management as soon as we get done talking about architectural design and the design document. And hopefully at this point you have your analysis document done, you have your requirements document done, you're taking the midterm, maybe not. You're going to upload it. I hear the links aren't working in the EMS, so you might have to wait a few weeks for the links to actually work. It's work in progress. So let's see what we have here. This is where I was told we stopped. Okay, very good. So let's continue. So I was talking about software architecture, and this is the first part of the design document, generally in the top section. And because this is the big picture. So a nice way of approaching the problem of describing what you want someone to build is to give them the big picture and then give them the smaller components and then tell them how to implement those smaller components. When I say how to implement, I don't mean write the source code for them. I mean tell them the specifics in terms of the requirements for each one of the components. And so the software architecture is the process of designing the global organization of the system. It could be breaking it out into subsystems, so dividing it into subsystems, deciding how the subsystems are going to interact with each other, determining the interfaces between those systems. And for those guys who took the software engineering 2 first before the 1, this is the foundational information for that. In that class we looked at different architectural designs. And we looked at network ones, distributed ones, different models for it. Now I'm giving you the foundation material that was supposed to go before that class. And in terms of the core of the design, this is the core. This is the underlying design itself. And it's basically, the audience for this are the engineers. It's not for the consumer. It's not for the end user. Because they're going to see the prototype, which is hopefully going to be made from the design. And at the time in which the design is being created and the architectural design is being established, that's when we can start prototyping it. Because we know all of the different modules of the system, we've already broken it out, we've got the pieces, so it's really easy to make dummies of those pieces, put them together. So it may be a paper and pencil prototype, it might be a software one, it might be something that shows the architectural design in terms of the software architecture. So it's often constraining the system's efficiency, reusability, maintainability. It gives all the characteristics of the software for which it's going to be built. And a big component of this is reiteration and iteration, I should say, and revisiting this again and again to make sure that we not only have we completed all of the subcomponents of this, but we haven't missed a subcomponent. Because sometimes when you draw the big picture, then you start looking at the little pieces and you go, wait a minute, don't we need a print module? Or don't we need a save module or something? Or what about the database? And and then all of a sudden you start seeing the pieces that you're missing. See, the importance of software architecture in general enables everyone to better understand the system, allows people to work with the individual parts of the system in isolation. That's key. Because if you were doing any project management along with this development effort, you have hopefully split out the work and you have multiple engineers working on different things. One person could be creating the architecture for the database, another person could be doing the user interface design, and yet even another person can be working on the design document itself, somebody else could be working on the prototype, and if you're working in teams in this class, that's what you could actually be doing. Somebody could be working on the design document while somebody else is doing the prototype. And you're wondering, well, how can you do a prototype something that's not finished yet? It's based off the software architecture. So once you guys do the architecture and you have the overall big picture, then you demo it. Then you can show you the big picture essentially, or prototype one small component of it that's maybe hard to understand. And so it also prepares for extension on the systems. So if you look at the design document right in the beginning, you can see the overall software architecture. You can see where a new module might be able to be put in, or whether the system can be expanded upon and stuff like that. And it facilitates reuse and reusability. It gives you the ability to take an existing component and use it for another functionality or another feature, or take an existing component from external to the system and use it inside of the system, or swap it or communicate better through a networked application. I forgot my watch. Hold on. There we go. We don't have clocks in the building yet. I think that's after the desks. Then we're going to get clocks. Those are expensive, those clocks. All right. So contents of a good architectural model. So it's often expressed in terms from several different views. And this is kind of like what we looked at in the Software Engineering 2 class, actually. We looked at the different views. The different views were the logical breakdown of the subsystem, the interfaces among the subsystems. Depending upon the view that you're trying to achieve, you're trying to represent, you're going to have a different model. And in Software Engineering 2, we pretty much looked at the different models. So in this class, what we're doing is looking at the underlying concept of what are the different views. And there are different perspectives of seeing the system. So if you put on different glasses and you looked at it, one of them would show you the interfaces, another one might show you the networking protocols, another one might show you the class hierarchy or the class structure, and maybe the interactions between the components or something of that nature, the reusability of the components, which ones are being reused, the data that's being shared between the systems, the components that might exist at runtime, might be on different machines, might be located all over the place, how they work together in terms of interworking components in a networked environment. So depending upon the view, you would represent a diagram that was showing some characteristic that you needed to understand. If this was an ATM banking program, I'd say the data would be important, and also the network connectivity. The user interface view, probably not so important. If this were a mobile app, the interface view, or how the buttons and the controls were going to work or something like that, or how it was going to interface with the library might be a good one. And we haven't actually gone through this part of the lecture, but we actually did look at the design document several times already, so I'm not going to pull it back up again. I'm going to assume you guys are familiar with it. In terms of writing a good design document, which is what you probably at this particular avenue in the course, you should be putting this design document together. Here are some of the things that to keep in mind when writing it, and this is kind of good, goes along with good design patterns or good design philosophies. So the design is going to hopefully make better decisions. So design documents are aided to make better decisions for you in terms of making better designs. So when you put the design document together, you're taking your analysis that you've already done and you're deciding on, well, which approach do we want to go with first? And that's where you have that other section where you have some, at the end, alternative approaches. So you're going to decide, and then you're going to include documentation in the design that's going to show or demonstrate the design that you've selected. So it forces you to kind of consider important issues, starting at the beginning of the implementation, the overview of it, the architectural design. Also allows groups of people to review the design. It allows a sharing document. It's hard for one person or one group of people to explain, here's how we're going to design the system, to another group of people. And then, what are you going to take notes? Are you going to take pictures of it? This is kind of a standalone, kind of like a Google Doc if you think about it that way. The purpose of that is to kind of share information within a group and have everybody contribute to it. And not everybody will probably contribute to the writing of this document, but they can certainly review it and say, well, you left out something, or this is not clear, I don't understand this part. So it allows for communication and for group improvement. And the document as a means of communication, it's for the audience who is going to be implementing the system. So this is the design you send out, to the outsourced company and say, here's the design, build me the software. And hopefully it's complete enough so they don't have to make any, make minimal assumptions. They don't have to make any big assumptions. And they can put it together and send you back something that it works, hopefully. Kind of a big if. Depends on the quality of the design. Those also who might need the design in the future to understand the system to make modifications on it further down the road. So yeah, you're Wells Fargo and you built this system, and then all of a sudden somebody invented ATM machines. Because believe it or not, there was a time when ATM machines didn't exist. Well, in this country and probably elsewhere as well. And now all of a sudden we got this ATM concept. Are they going to change all their banking system to brand new software? No. They're going to go back to the original system. How do we integrate the ATM transactions with our regular system? And then if you pull the design document, hopefully it exists for the project. And then you can kind of see where it fits in, hopefully, and modify the system in the future. And for those who need to create subsystems that interface with the system, it's also good to have the design document as well. Let's say you want to create an Android phone application so you can do online banking for your Wells Fargo. Well, it'd be nice to have an API or something to work with. It might be nice to interface with the banking module or something, or online services that are provided by the bank. So, if the interface is documented, then you can use it, hopefully, to make a better app or something. So, when writing the document, here are some things to avoid and some things to do. And this is what I gave you, similar to what I gave you with the requirements doc. And then the biggest thing about the requirements doc was being specific and listing out each requirement on a separate line and not including multiple requirements in the same sentence. So the document for the design is very similar, but you want to be a little bit more broad. You don't have to be as specific, because the more specific you are, the more you're constraining the design of the system and making it so it's possible it can't be implemented. So you want to avoid documenting information that would readily be obvious to the skilled programmer or the designer. Don't teach them how to program. Don't just point out modules or packages or something that they need to use. Because you don't want to insult the designer. And plus also you might be wrong. It might be upgraded. Something may have changed. And so that's kind of a fine line as to, well, what's readily obvious? And who are these skilled programmers? So it's kind of that's kind of an issue right there. So people usually go one extreme or the other. They just say build it, and then some people go build it in Java JVM, build it with the Java SDK or JDK 2.0, and make sure you use the IO stream, or whatever. I don't know. Actually, no. It was Java. It's C++ the other day, so now I'm going, what is Java system.out or whatever for this and for that, whatever. And then it's like people just stop reading it at that point. So avoid writing details in the design document that would be better placed in comments in the source code. So yeah, avoid writing the source code as well. Avoid writing pseudocode, and avoid writing comments that don't belong in the design document. Avoid writing details that can be extracted automatically from the code as well, such as a list of public methods. Don't give the class diagram. Don't specify out every one of the implementations, the methods, and the things that are associated with each one of the classes. You can recommend a class hierarchy, but I wouldn't bother putting the details in there unless you know for sure that these details, or this is one approach, and that these details are relevant, I should say. So here's an example of a design document for a chat system, and I'm going to point out a few things in here that, some things to watch out for. This is the template that's on page 76 of the class notes. I'm not going to bring it up because I've already brought it up a couple of times already. It's interesting because right here in the beginning, in the goals and the objectives, we can kind of see that this design document is important, is only describing the implementation of these these four different methods, or commands, I should say, of the chat system. So all of the content is associated with 1, 2, 3, 4 different commands, which means it's an add-on. If they're creating, the chat system already exists, and they're creating the addition or supplement of these 4 different features. So the scope here is describing it. The decisions of the document are based on the following priorities: maintainability, usability, portability, efficiency, and that's kind of garbage if you think about it. It doesn't really say very much of the scope, except for it's what's describing the objective or the goal, but it's kind of broad in my opinion. But in terms of the software context, and this again is just one example, and it varies a little bit. It varies a little bit from the template that's on page 76, and as I mentioned before, break it out the way that it's specified in the template, but you can be creative with the different categories. In terms of the software context, the blocking information will be maintained by this connect to client object, and it's talking about these objects. Various other commands will upload, query the data, set object, get value, or set value, get value, stuff like that. It's mentioning methods. You can do that. you can actually, because in some of your diagrams, especially if you're using a UML object diagram, you're going to have objects in the diagram. You're going to put labels on them. So you've given already the architectural design of the system. And you're talking about this particular component. This component has a connect to client object. And in that object it has a set value and a get value. So you can talk about those. And then the major constraints, one issue, where should we store the information regarding the establishment of blocking? For example, probably on the server, I would say, but store the information in the connection to client object associated with the client requesting the block. Are they going to get it from the server? Are they going to get it from another place, a text file? But it kind of gives you the options here, option 1. Option 2, store the information in the connect to client object associated with the client that is being blocked. So you can list off alternative decisions or alternative kind of approaches or options that you can make or decide upon. You don't have to decide. I guess what I'm saying is you don't have to decide in the design document. You can just kind of mention that, one of the things we have to think about is where we're going to store the blocking information. And you might not know the answer to that, but the design implementers are supposed to. So you don't want to do their work. You just want to mention what you can from understanding the design. These are some of the issues. And they can come back and tell you, well, we like option number 2 better than option number 1. And we're going to go with option number 2. And you can come back and say, okay, that's fine. In terms of the decision, point 2.2, the requirement, specification requires that we be able to block the client when the client has not logged on. So it means you must choose option 1.1 since no connection to client will exist for the clients that are logged off. So option number 1.1, store the information in the connect to client object. So it's on the local client machine. And that's just an example. Obviously, this is for a chat program for specific information. It may not necessarily relate to your project, but you might have something like that in your project that might be kind of unique in terms of a decision that you'd have to make. And it's just the logic, because what you're trying to do is point out any constraints, and this was the major constraints category. And that would be an example of a constraint. If the user's not logged in, how are they going to know if they're blocked or not, or who's supposed to be blocked? It's kind of like your address book for an email program. Where should you store that? Probably shouldn't be online. Or maybe you should have access to it even if you're not logged in, because how are you going to get the addresses to send a message unless you've sent a message? So some of the logic in terms of the constraints can be listed. Outside of that, we go into 2.0, which is the data design. So the categories should be specific for your project. So if it's component 1, component 2, component 3, that's what's this 2.1, 2.2, and this is a client-server application. So we have the 2.1 is the client side, 2.2 is the server side. Right up here, oops, there it goes, server side. So we broke it out into component 1, component 2, component 3, as I mentioned before when I went through the document template. And for client server app, component 1 is the client side. And so, there's 4 new commands that will be accepted by this particular, and there's going to be responses that come back, and you kind of list those out. And then for the server, there's going to be a method to interrupt the block, and all these commands are going to be used for that. And some more methods down here for the handle the message from the server UI, and it's all specific. You kind of see this information here is kind of programming like. You can do this, just don't write the whole method body. Especially if this has got an interface with something that already exists. In this particular case, it's so specific because these are add-on features to an application that already exists. So we can do this. Normally you don't want to do that. If the application doesn't exist, you don't want to start writing the source code because it makes too big of a constraint. And here's the implementation of the who I block. And you can just follow through it. It doesn't really make any sense unless you're familiar with this application. But these are just methods that are discussed or that are described. And then the chat system runs on a client-server application. And here with the program structure and the architectural component level designs that you want to put together. These are just pictures that are going to show this stuff. That are going to show everything in the data section. Because the more you show it, the better, or hopefully the more understandable the specifications are going to be. And it's all about, graphically and then verbally or, textually describing how you want this thing implemented. So there's a simple picture that shows the architecture graphically. We got a VAX server and a Unix workstation and a mainframe. We got clients out here, and they got a TCP/IP connection. So it's kind of a. You'd think, well, this is kind of kind of simple, which is good because when you look at this, you go, oh, there's a VAX server involved with this. Oh, okay. So you might actually see something you didn't see in the past. So. And then in terms of the rest of the design, the description of the client. In 3.2, description of the narratives of the interfaces, the interface for the UI, the interface for the processing, the details and stuff like that, description of the server, description of all the external, the internal, and the human interfaces, which is basically this third section is just the UI. Most of you are just building a UI for it. You're not going to have a server interface. It depends on your application. You might have some sort of an interface with another system or something. So. Anyway, that's the design document template that I've gone over so many times. I don't think it's really, unless somebody wants to see it again, I don't think it's really needed. We're still recording good. This thing keeps going away. I remember a couple weekends ago, I had a weekend class going, and I went through like 3 or 4, almost 3 hours actually, because we were trying to get done at the end of the day. Then I realized that the recording stopped. So I'm like ultra cautious now. I'm just checking it over and over again because I'm like, is it still recording? I can't tell. Especially when the icon goes away from the menu bar. Then, like, I don't want to lose the recording. All right, so this is lecture number 14, unless there's any questions on 13. That was kind of the wrap-up / conclusion of the. I know it was like a week ago that we talked about that stuff, so I probably don't remember, but that was the wrap-up or the conclusion on the design document. Now, at this point, you have everything you need to know. And I'm going to talk about prototyping, but I'm going to wait another couple weeks before talking about prototyping, because we still got the rest of the month left for this class, so we're not quite done with it yet. We have miscellaneous topics, and the next one miscellaneous topic is called risk, so risk in software engineering. Because what we're doing when we're writing all this stuff up is we're trying to minimize the risk of failure, risk of losing all our money, risk of wasting our time, different types of risks, and the concept of risk management is at the core of all of these concepts. And in terms of what it really means, it's a proactive approach to reacting to project change. So we started with a waterfall model. You're only doing this for 15 weeks, but what if you're in a company and you're doing it for 2 years? And the project's lasting a couple years. Well, right in the middle of the project, something might change. Somebody else might get elected as president or something. I don't know. Some company might go out of business. Some technology might become obsolete. Things happen. So you have an ongoing risk assessment activity that constantly monitors, checks to see if something happens. And when events do happen, the project is not on an island of its own. The project can actually react and maybe stop working or, close down, stop if it becomes obsolete. Because why are you going to continue spending money on something that you're never going to put on the market? Or maybe, might switch gears. Or who knows, maybe the concept might change or something. So that's part of risk management and risk assessment. And the part of the management aspect of it is to identify the risks that are associated. To figure out, well, what is it that we should be looking for? Communicate the risks to the project team and monitor for it and mitigate, and then come up with some contingency planning. So we can't, look into a mirror ball and predict the future, but we can kind of put like checks in to say if we're not past a certain point at a certain time, we're never going to finish on time. We don't have this done, we don't have that done. If we run out of funds in the first week, we're not going to make it till the end. And the risk might be running out of money, might be running out of time, obsolete product. If you go to page 82 and 83 of the class notes, you'll see different types of risks. The ones that fall into different categories, such as which are important, are the predictable risk. So predictable types of risks. We have maybe a strategic risk, strategy, market strategy, competition, financial risks, project management risks, technology risks. Especially in the technology risk category, believe it, this is actually one of the biggest ones these days because things are changing rapidly. You know, what used to be acceptable for a mobile device isn't anymore. And if you're in the mobile device market making apps and things, you know, the market's changing, the technology is changing. People are essentially putting themselves in a hole in some ways because they've gotten too smart to the point where consumers expect a lot. The risk of the consumer liking your product is really, really something to consider these days, because if nobody likes it, you're not going to sell it. And if something else has got a bigger name or something else, you know, I mean, competition is really bad, I guess is what I'm saying. And that would fall under both categories. That would be a strategic risk and perhaps technology risk. If you can't keep up technology-wise, or if you can't strategize your marketplace correctly, that might be a problem. Failures and risks. So software development projects can fail in many different ways, and we all know about the no money and the late. We're late on time. We might have a bad software engineering, and that's basically the over budget and late. Lack of function, full of bugs, maybe some bad performance, maybe late, over budget. And then we also have changing circumstances that are above and beyond the control of the project team, but they can't be ignored, which a lot of people actually do. In fact, a lot of people work on consulting jobs, and they're working on projects that have been around for a while, and they constantly bring new people in because the old people are leaving. The old people are leaving because the project's failing, but nobody notices this yet because nobody's monitoring the risks. And the problem might be that the technology is old, or the project team's behind schedule, or nobody believes in the concept anymore, or the concept's already been done, or any variety of different problems in terms of changing markets. Better alternatives might come out, and in that particular case, why is this team even continuing? There's a better choice on the market, and maybe also changes of management. Some people with different visions, different goals. So the biggest single source of problems is poor understanding of the requirements, actually.
Changing of models can be considered better alternative.
Say that one more time.
Changing of models, development models.
Yeah, that might actually be changing. Change of management might come in and change the model on you. And the team doesn't work well with a different model, or the model's not working right. Which is kind of interesting. I mean, for example, if you're working in a Google environment, you're using a totally different model than if you're working at IBM or HP or something. Some management people come in when they have these, really exciting brand new ideas. They want to change the world and are innovative and stuff. And some of their stuff is really bad. Half the team buys into it, and then. Well, it's kind of like what the whole Carly incident over at HP, if you think about it. Come in, fire everybody, move your manufacturing offshore, lose control over everything, and change the methodology completely. And then the company figures out, ooh, really bad. We've lost a lot of money. And then fire that person, bring somebody else in, who brings it all back to the U.S., who decides, this is a better methodology, this is a better way of doing it. Let's not be so innovative. Let's just settle on some product lines and let's focus our efforts a little bit more, And that might help. So that's a classic example, actually, of many projects that failed a few years back in the HP days. In terms of managing the risk, managing the projects to avoid the risk. So part of your software development lifecycle activities is to avoid the risk. That's why you're doing it. Because if you come up with a list of requirements, then the requirements aren't going to be unknown. You're actually going to know them, hopefully. And if you build the design off of the requirements, then you're not going to miss any of them, hopefully. And you have traceability that goes from requirements to the analysis through the design document. And maybe you have traceability to the prototype and hopefully to the end product. And then you have your acceptance testing. And if you're thinking about testing and you're moving it in, making it part of the development lifecycle model, that's going to reduce your risk. So in essence, by following a methodology in general, you're doing risk assessment, whether you're part of the risk assessment team or not. In terms of some of the things to manage to avoid the risk is open and visible software processes. Actually documenting the software processes is interesting because it avoids surprises and it lets everybody know what's going on. And then it allows other people to kind of assess what you're doing and say, well, hey, you should, could you tell those guys not to play basketball? Okay, thank you. And they just started and it's going to get louder. Long story short, if you have documented what you're doing and you have visible, clear processes, people can actually help you improve that. And other teams can look at your processes and assess what you're doing. Continually reviewing the requirements of the project. What is it you're doing to make sure the requirements are realistic and they're properly captured. Willingness to modify or cancel the project is actually a good point as well. There are a lot of people who don't want to cancel a project. And I've got some interesting slides coming up here with some really good examples of historical events that are true, have happened, and in each one of the scenarios is slightly different. Example, the Andrews Windows Manager. And it was technically superior to X, MIT's Athena project. This is back in 1986. Unix related if you're not familiar with the concept. But Digital Equipment Corporation turning X into a product with massive support. Well, X got more support. Actually, X is still around, actually, too. So nobody really supported VM. There weren't any groups. There weren't any companies that supported it, like Digital Equipment as an example.
Window Manager is a part of the Windows system, whereas Digital Equipment is a Unix system.
Yeah. Well, the concept, when it was coming out, it actually came out as a separate project. And they actually ended up having to cancel it, but they ported all of the interface stuff to X. They became part of the other, which is why a lot of companies actually merge. Because, you're a small company, you're not getting any support, but you have a good product. And they had an excellent, obviously it's still being used today. Excellent concept, excellent research. But they didn't have any backing. They didn't have any company backing, so at one point you got to stop. And nowadays what they do is they just look for someone to buy them. That's the smart thing. But I believe it was university-run research that started that, so they're not necessarily thinking like business people. So they're not going to get bought out. Instead, they canceled it, and the interface got ported to X, and it became part of X. In fact, VM is the Windows Manager itself is actually core to a lot of concepts we're using today in a lot of operating systems. So. In terms of failure to cancel a project, here we have, and this is interesting because each one of these scenarios, not only has it happened before, but it's still happening today. And you would think someone would look at that and go, like if you're trying to compete with an Android market right now, are you going to do that and be successful? Yeah. And then are you going to fold and put your concept into the other product willingly? Or, or maybe, hopefully you'll get some money out of it, which is pretty much, it's like, what was it? Oracle, going with Sun, or I don't know. Google just bought up somebody else recently, small guys. But now it's just one company acquiring the other. But in the old days, the companies would just go on forever, losing money. It's like, but not get bought out. They end up folding, closing. Someone say, hey, can I use your technology? And here, sign on the deadline, release it to me. Okay. But it has value to it, so kind of the corporate strategies have changed recently, but historically things close all the time. Failure to cancel. University F, F develops a novel programming language. Actually, a lot of programming languages get developed at universities, or used to get developed at universities. From 85 to 89, it was a promising language for simple programming, window-based applications. 1990, clearly not gaining acceptance beyond the university. But development continued for many years, about 500,000. Why? Egos. Not canceled because, all the instructors' egos or something got involved, and there really is no answer. They should have just canceled it. But it was research. They thought maybe something was going to come out of it. It's like people do all sorts of things over and over again. They continue to fail at something. And then they just continue to fail and fail and fail until one day they just run out of money, maybe, or I don't know. But, they used to call that the entrepreneurial spirit in this country. In this country, you can be an entrepreneur. You can do whatever you want and fail at it miserably, over and over and over again. As long as you're using your own money, or if you're using anybody else's money, you got to justify why you failed, I guess. It's called venture capitalists that aren't going to give you that money. So. But you're allowed to fail. I mean, that's no problem. So, but people don't want to fail. It's a negative, right? But, believe it or not, there's companies that go into business just to fail. It's counterproductive, but maybe they want to get something done. They have an algorithm they want to implement. They want to see it. One guy in an engineering department wants to see something happen, gets the work through this company that they know is not going to make it, and then he takes the intellectual property and runs. Or buys it from the company that failed or something. Because it's not going to work. But if you think about it, every one of these failed companies are learning experiences. Now you know what not to do. So, maybe too big to cancel. Now that is counterintuitive. I've spent too much. It's like, here's another thing that happens in the U.S. all the time. It's called the money pit. You buy a company, you acquire a company, you start a company, you throw money and money and money and all, it could have been ITU actually. You throw a bunch of money into it, and then you don't get your accreditation, or you don't make it, and you fail. But it's too big. You've put so much money into it, you're hanging out, putting more money into it in hopes you're going to get some money out. It's like the whole gambler's philosophy. You go to Las Vegas, you got a couple $100, you lose it. I lost a couple $100, so you go to the ATM, or you just pull out more money out of your pocket. You put more money down, more money down, more money, because all you have to do is win one time, but you keep soaking money into it, and then eventually you walk away losing $1,000. Or you win big, and you start putting it back, and why do you put it back? You just stop right there, walk away. Who's going to walk away if they win big? Nobody's going to do that. It's too big. So too big to cancel. University A has anticipated administrative system. Senior management decides to replace them all with commercial packages from X. The timetable and the budget are hopelessly optimistic, unrealistic. Staff gets dispirited. The chief information officer finds another job. The new chief information officer is appointed. What should she do? Well, she probably should assess it and cancel it. But then you're going to cost the company a lot of money. But sometimes it makes sense to cost the company a lot of money. In fact, that money might be less than if you continued the project for another year and then cost the company a lot of money, because eventually it's going to fail. It's like, and I kind of said this one time, and I can't remember, I think it was at a different school. I said something like, you already dumped a bunch of money in and you got some money left, right? And the project is failing. Go take the money and buy a car with it. Or use it as a down payment for a house or something, and just close the company. And then, someone looked at me and went, "That's not a bad idea." Why throw it in the fire? It's like you got a big, huge fire, right? You're gonna throw everything you own into it. You save some stuff. Close the project and buy yourself a nice car. You can be happy with your car, and find a job, or do something else. A lot of people don't want to do that though. So they just throw everything into it. Just throw it all in. You know what? It's pride of ownership. Most mom and papa small businesses in the United States, and probably the same thing elsewhere, they don't make a profit the first couple of years, but it's pride of ownership. It's the family business. It's the store. It's the gas station or something. And even though they're not making any money, they're still doing it because there's a hope for the future, and they have something that they own, and they have pride in that. But if they just sold it, got themselves a 9-to-5 job over at McDonald's or something, they'd probably make more money. Anyway, that's scenarios. We're doing it the wrong way. Another classic problem. University B has a big joint project with Company Y in developing a new computer operating system. After 2 years of work, the junior software developer persuades the university leader that the technology approach is all wrong. Uh-oh, we're doing it the wrong way. What should the university do? What should the company do? Cancel the project. Start over again. Do it the right way. Because if you know you're doing it wrong, this actually happens with the government all the time. And you can notice it when we have earthquakes and the bridges all fail. And things collapse and they go, "Oh, didn't anyone check that?" No. Well, it was defective, and we knew it was defective when we built it, but we put all the money into it. What are we going to do? Tear the bridge down, build it again? No, we're just going to wait to see if we ever have an earthquake where it's going to actually come down on its own. It's like, okay. Or, not checking gas pipelines regularly to make sure they're not corrupted through 20 or 30 years of corrosion underground. Stuff like that, Why bother? So how to stop gracefully. So it's harder to cancel a project than it is to start it, actually. It's because you got to decide to stop it. It's harder to withdraw a service than it is to introduce one. Considerations: a portion of the system must now reverse their public stance. So a lot of it is actually media-oriented or public stance-oriented. To make up, management, the expectations of management have to change. The vision has to change. Users of the service need to migrate over to something else. Like as an example, if Google were to go away, let me rephrase that. Google's never going away. Gmail. If Gmail were to go away or something like that and it was replaced by another technology or something, then, maybe for 6 months, it'd probably take about 6 months, I think, for that to happen, actually. Or actually, eventually, hopefully, this EMS is going to go away. It'll take about 6 months, maybe, for that, 5 minutes for that to happen. And then all of a sudden, you got to migrate people to the new system. You have to, give them free accounts for 5 months or something, or, to compensate them for their effort. Otherwise, you're going to lose the market. So, strategies like that you actually have to come up with if you're going to fail. So, because you might have some people who pre-bought. What about your investors? Stuff like that. And it's really a business strategy. Technical staff must have a graceful path forward, hopefully. Maybe here, we're now got bought out by this company. Here, go interview. See if they'll hire you. So the time to complete the software project. Large projects typically take at least 2 years from start to finish. Then we have the formative phase. Changes in the project are easy to accommodate. In the implementation phase, not so easy. Fundamental changes are almost impossible. So that causes the projects to fail as well, is not managing change and having things like scope creep and stuff happen to you. Many things change over 2 years, however. So it's going to happen anyway, whether you control it or whether you don't control it. Might be an issue. In terms of risk management, another thing, it might be the sense of urgency. And this traditionally happens with large bureaucratic companies, large bureaucratic governments. There's no urgency at all. Because it's a job. It's a 9 to 5. If you finish the project, you don't get paid anymore. So it's counterintuitive in terms of urgency. A nonprofit corporation is developing a system for the government organization. 1996, all the research has been completed, and the system demonstrates successfully with real users. 2000 system is still not in full production. 4 years later, after it was already proven and it was already successful, reasons why: incremental improvements to the software. We can build it better. We can build it better. Oh, let's rewrite it in a different language. Let's just do it this way. Let's do it that way. Let's add this feature. Let's add that feature. Repeated requests for more functionality. Reluctant to reorganize the clerical staff. Or anybody. No, so nobody had a sense of urgency. So, actually, as a side comment, this happens in companies that are too big, usually, because things get lost. They go through this thing called a loophole, or they fall through the cracks, because that so-and-so was going to sign off on that. So-and-so, and then nobody signs off on it 6 months later. Has this been signed off yet? No. So large groups of people have a tendency not to work well together, which kind of makes the small startups, more innovative, quicker, faster, more productive sometimes than large companies. So. Overtaken by events. University C has a project to develop a digital library system with funds from Company Z, private foundation, and the government. 1993, an extensive system is running at the university. And Z is marketing the technology to its customers, and then a year later it's clear that the web browsers and web formats, through technically weak, are becoming wider adopted. It's kind of like trying to run a bulletin board these days. Not going to happen. So the internet came out and actually wiped out all bulletin boards. And this is kind of the concept, actually. It was a bulletin board concept. What should the university do? Get on the internet. take the bulletin board down, convert their application to a web application, essentially. And so should the company. Should pay for it, because it's overtaken by, certain events. Well, example, notebook computers are overtaken by tablets. So in the future, we won't have notebook computers. Well, really? Probably we'll still have notebook computers. The tablet market is replacing a lot of the sales for notebooks because they're doing the same thing. They're supporting Microsoft Word. They're supporting email, web browsing. What do you need a notebook for? And I seriously doubt they're going to totally go away. But the concept of the notebook might change, to more tablet form, which it already has, actually. A lot of their tablet notebook hybrids are on the market. So changing requirements and the design itself. An example here, CNRI handle system. High-performance distributed system for mapping names to resources. 1994, 1999. And then we got all this other stuff. We got the web browser. Back in 1994 was Mosaic, not exist anymore. Java didn't exist. Monitoring caching utilities were not available. Commercial interests were not available, were limited. So you made decisions made back in 1994 had to be changed. You can't base everything on decisions. In fact, that's happening right now in terms of cloud computing. You can't base decisions upon service providers right now. You gotta wait. And if not, you got to change anyway because everything's going to be cloud-oriented, or if it's not already. In fact, a lot of stuff is already transferred over to that. So you build your application on a cloud platform now instead of on a private server. So, your decision, your requirements, your design is completely different now. If you don't adapt, you end up failing. So you have to adapt. If a job's worth doing, it's worth doing twice. It is, actually, because if it's worth doing. So, changes of leadership. This happens all the time as well, sometimes voluntarily, sometimes when new management is appointed. So in 1988, Company W gave University D $1,000 to port a new operating system to its personal computers. The work was well done. On time, Company W changed its president and senior technical staff. During the project, the work was wasted. Stopped the work. A decade later, several of the presidents later, Company W is releasing a new modern version of the same operating system. So it was a good idea. Somebody came in, canceled it, said, hey, this is a bad idea. That person left. New person comes in, said, wait a minute, it was not a bad idea. It's a good idea. Let's continue. Resurrects it from the dead, changes it, updates it, and voila, it's a successful project. So canceling something in the short time, or change of leadership. So a graduate student from University D is now senior vice president of the Company W. So, they got a job over it. Client oversight. That's an interesting problem. In fact, this happened with a lot of internet development in the beginning. The internet back, I would say, in the late 80s, early 90s, was 70% males over the age of 45. What do you think it is today? Well, the age group is now 25 to 35 is the biggest one. And it's like over 60% of the people are between the ages of 25 and 35 from the last. You can go online, actually, and get the statistics for that. But I believe, don't quote me, but I believe that's what I remember reading last time I looked at it. Significant change in the client for the internet. Most applications are for young adults now. They're not for old men. Or let's just say over the age of 45 is not really old. But it's a different demographic is my point. So, although the same statistic, now I got to go look this up, the same statistic said the average most visited content was still pornography, actually. So pornography still holds number one on the list of suggested, not suggested, but most viewed content. So, but it's nice to see that the age group has changed. So, things like Facebook now. Well, I guess the 25 to 35-year-olds are looking at pornography and social networking. I don't know what they're doing. So, client oversight. Another reason why I mentioned that example. As Company G as the world's leader in software for optimization, let's say linear integer programming, G had implemented several packages for various different manufacturers and operating system. for Company H, contracted with G to develop an optimization package for their new operating system. The package was late, performed badly, and disliked by customers. Wrong audience, wrong customers. But perhaps if they sold it to the right company for the right purpose, they would have actually been successful, perhaps. So people who are building applications for the internet, if you keep in mind that your target audience is probably about 25 years old, then, and they like pornography, you can probably make $1 million off of that. But if you go to Housewives or, I don't know, if you try to go back to the age group and you make it into cooking or something, or into something that's non-liked by the majority groups of people who shop on the internet or who surf the internet, your chances of success are going to be limited. So, what I always liked were all of the, you guys, I don't know if you get, well, you don't know if you were around in the States back in the .com era. Were some of you here? This is about 10 years, this was almost like 10 years ago by now, I guess. Back before the bust. You could watch TV ads for pets.com because pets don't drive. That was the slogan. Pets.com. They were advertising on television internet websites. Stupid idea. Stupid. Because why, if you're on the internet, you should see the ad, or you should market towards internet people on the internet. People who are watching television are watching television. They're not on the internet. And who cares if pets can't drive? Humans are buying the pet food. Do you want to buy pet food on the internet? No. I don't know if you've seen the pet food that they have. I don't have a pet, but I've seen the pet food. Huge 5-10 pound bags of pet food. You going to ship that? And pet food is actually kind of cheap. So you go to the grocery store to buy, or you go to the pet store to buy the pet food. Otherwise, you pay $20, $30 to have it shipped to you. Bad concept, bad marketing, bad image, bad everything around. And actually, companies like, you guys are familiar with Webvan? Have you ever heard of Webvan? That was another one of these crazy products. Actually, there's a lot of people who thought it would work. It's actually what the grocery stores are doing now, but slowly phasing out, cutting out completely. Webvan was a service you can go on the internet and buy groceries, and then the groceries would be delivered to you. However, most people like to pick out their groceries, especially produce, vegetables, stuff like that. You're going to let somebody else pick it out for you, and then receive it after it's been in a van in transport for 5 or 6 hours. So perishability was an issue, quality of the goods was an issue, price was an issue. So as a business model, failed miserably. It was too expensive to refrigerate the trucks. And now we have, this is a good example actually, projects that failed. Gas prices went up. They weren't as high as they are now, but they were certainly going up. They weren't making any money on that at all. And then they advertised it on TV again. So you got people watching TV for Webvan. They're not on the internet, they're watching TV. Wrong demographic. So anyway, that was it was kind of interesting from a historical perspective. All the interesting yet failed ideas that everybody came up with, and all of these websites that came up out of nowhere. And a couple of them are still around. eBay's still around. That's a good concept. The good concepts are still there. So when people say, oh, the .com, the .bust, yeah, it was a bunch of garbage. It was a reason why all that stuff failed. Now we're a little bit more realistic in terms of products and services. May also be another failure, because we're talking about risk, projects risk, for those people who came in late a few minutes ago. Software engineering risk, managing risk. I guess the point of that last story was think of the concept from a business perspective and not from a, wow, wouldn't it be great to have pet food on the internet? I'd like to sell bricks on the internet. I wonder how a brick is like 5 cents. How much it would be to ship that thing? Heavy. Okay, so the project might be too difficult as well. So the developing team might build a high-performance gateway for protocol X to Y. Promising young developers was hired and assigned to the task. Yeah, promising, over-optimistic, over-enthusiastic. Yeah, I can do anything, developer. And the project was too difficult for him. But he hid the problems for many months. Actually, this doesn't even happen. This happens all the time, but it doesn't even happen with just cutting-edge technology. It comes with basic stuff. People get hired for jobs. Who's going to admit that they don't know what they're doing? Instead, they're going to pretend like they know what they're doing, but they really don't know what they're doing. And then learn what they're supposed to be doing while they're supposed to be doing it. So they're going to be late with whatever it is they're supposed to be doing. Or someone's going to figure out that they don't know what they're doing. And eventually, hopefully, get rid of them and replace them with someone who does know what they're doing. So, but you can't read the minds of all the people you hire. So, and this is a hiring issue. So the project produced nothing of value. And what can we learn from this experience? Pick the people well and monitor what they're doing and make sure that they actually know what they're doing. And also ask and open up the lines of communication. So if the person doesn't really know what they're doing and admits it, then in the first week, instead of after 6 months later, then they can actually add resources to it, fix the situation, and the project might actually be successful. And then we have the forever a problem between engineering and marketing. And most of you don't get software anymore in packages on the shelf. But back when they used to walk into a Fry's and see software, actually they still have packages. But who buys those packages anymore? Everyone downloads software from the internet these days. Back when we had manuals and printed stuff and discs and a box, and you look at the box and you see the screenshot of the product, and then you installed the product and you went, what program is this? It's different. It's because marketing takes the pictures of prototypes, or they make up. They're in a world of their own, and they need to get the box finished, manual printed, everything done for the product to ship while the software's still being made. So the features on the software and the pieces in the box don't match, usually. If they do match, then the product's in its second or third release. But the first version never really matches. And then also you get marketing people and salespeople who sell the product with not even knowing what it does or what features it actually contains. And then they sell it to customers, and the customer opens it up and goes, this doesn't print to anything. This doesn't do this doesn't do that. So, common age-old problem. So here we have corporate engineering and marketing divisions at cross purposes, which is the same problem we get today, actually, even with downloaded software. Not as big, not as obvious as it used to be. Xerox Palo Alto Research Center pioneered window managers, Ethernet, graphical user interfaces, font managers, bunch of stuff. Apple, Adobe brought them to market. IBM would not bring its first Unix workstation to market until the software had been largely rewritten. Didn't like anything. Wouldn't do it. Sun's early workstations were unreliable, but sold well. Well, it's kind of like the first version of Windows, actually. And this is, actually a good thing. This is the opposite of what I was saying. Instead of marketing being wrong, engineering's wrong. So, if you can sell the product and you get the product out there, you deliver half of what it is you say you're going to deliver, it might actually be successful. Kind of like the first version of Windows. Kind of like a lot of the previous, including Windows Vista, a lot of people like that. It had tons of problems. It was rewritten. But hey, people liked it. So it didn't really matter what the product was, what quality the product was in. Senior management dynamics, another problem. A director, shareholders appoint the president. The president doesn't want to admit failures. The president appoints chief information officer. He doesn't want to admit failures. The CIO appoints computer managers or computing managers, department managers. They don't want to admit failures. The computing managers appoint developers. The developers don't want to admit failure. Who's going to admit the failure? The people. Everybody pretends that nothing is going, that things are going well. Well, sometimes you don't hear it until you hear it from, in fact, in university settings, you don't know there's a problem until the students say it. How come you never offer this class? Oh, administration goes, I don't know. Goes back up a level. I don't know. Goes back up another level. I don't know. Because we don't have any instructors to teach it? Oh, I don't know. And then it comes back down. And then let's offer the class. And actually, it's kind of interesting. A lot of that stuff goes around here. A lot of that stuff happens around here. When you hear from the students, it's like, oh, how come we don't have chairs in the classroom? I don't know. Look at my folding chairs. How come we don't have desks in the classroom? And, I'm wondering how long these desks are going to last, though. Because some of them look a little rickety. I don't know. I might not have faith in technology, but they seem a bit lightweight for adults. Well, actually, you know what? Maybe adults are easier on the chairs than kids are. They look like desks for kids, though, don't they? Yeah. But they're bigger. They're not like the itsy-bitsy little ones. Hopefully you guys won't be standing on them and throwing them across the room and stuff like the kids would be doing. All right. Senior management dynamics. At least the troubles cannot be hidden. Directors try to blame the president tries to blame the CIO. Anyway, it goes back downhill. Developers grumble about their managers. What can we do better? Just admit stuff. So here's the reality of everything. The major computing projects are very complex. Inevitably, there are delays and failures. Few organizations know how to manage risk and uncertainty. And the best CIOs manage and minimize the risk. They focus only on the risks. Because if you think about it, that's what's going to keep you out of trouble. And have confidence in the staff who keep them truthfully informed. Hire good people, I guess, who communicate honestly, tell you, is this really working? And then you can say, no. Oh, okay. And have self-confidence to keep the senior people truthfully informed as well. On page 84 through 87 in the class notes, we have the risk management plan. And you don't have to create one for your projects. You'll be happy to know that, because this could be an entire course in itself. In fact, risk management is usually an MBA course. Crosses over into software engineering as a subject because software engineers need to know about risk management. You're in the blind. You're working with blinders on if you're not paying attention to risks. And examples in the course notes are good. How to basically develop a risk management plan and how one is developed. And the most common approach to this, which you don't have to do for your project, but it's not a bad idea to know about it, is to come up with a table and list out all of the risks and then estimate the probability of the occurrence and the impact on the project using some sort of a scale, like a low end, like number 1 being a low impact, number 5 being a catastrophic impact, like major problem. And then perform these activities in terms of mitigation planning, monitoring, and then management. Because it's one thing to actually come up with a risk assessment plan and another thing to actually enforce it or to use it. So a lot of people come up with a lot of plans and then they never follow it or they never monitor the risks. And then the risks happen, but they don't even know there's a plan. You know, it's kind of like when well, actually this building is a bad example. It's not like when the fire alarm goes off. In hotel rooms, if you've ever noticed on the back of the door, there's the escape route, the plan you're supposed to follow. And I've just noticed that we don't actually have one in this building. I'll have to suggest that. There's supposed to be like a common location in the building for what happens when there's a fire, or what happens when there's a, an event that occurs, earthquake or something. And usually there's instructions written on a wall or something. In fact, like fire hydrants, if you ever looked at the fire hydrant, there's instructions on the fire hydrant. Just in case somebody who's never used one before picks one up. Which would be not only coming up with a risk assessment plan, but monitoring, meaning people know where to look for it. People monitor, have the correct resources in place, find it, and then manage it. Read the instructions and then use the device. So, as a preventative measurement is, as it applies to software, how can you avoid the risk? What factors are you going to track in the software development to determine that the risk is becoming more or less likely? And then, if it does happen, what are you going to do when it becomes a reality? So, which is essential, in terms of what you're looking at. If you look up through page 84 through 87, I believe, in the course notes, you'll see everything you ever wanted to know about coming up with that metrics. So, I think that slide said something about Java programming. We're not going to cover Java in this course. We are going to talk about prototyping, though. We're going to talk about GUI and prototyping designs probably next class meeting, because that's your last deliverable for the group projects. Java design techniques, nah, not going to cover that, actually. I've decided not to. But we have a couple miscellaneous topics coming up. Prototyping being one of them, software metrics being another one, assessment stuff. You do not have to do, if you're looking at, because a lot of people at this point are wondering, well, the class is going to be over soon, another month or so. When's the final exam going to be? I've actually, the other day, Monday, actually thought about this a little bit. And I'm thinking maybe the first couple weeks in August. Because technically the course is supposed to be over with on August 16th through the 20th sometime. And I like to do 2 weeks for the exams because it's just the sheer number of students. It gives you more flexibility when you can show up. And I'm thinking about the first 2 weeks in August. I don't have the schedule ready yet. But I should have it ready soon because this is already the 15th or so. This week is like the midpoint of July. So I have 2 weeks left before final exams start, actually. Which means we are kind of getting close to the end. Now that I think about it, I'm starting to see the end of the tunnel. This is the light at the end of the tunnel here. Then this has been an extremely fast term then. Feels like it's been fast. But we still have a couple weeks left, so within the next couple of weeks, I'm going to have the final exam schedule ready. And there'll be some flexibility just like before, and I will also review before to figure out, so to give you an idea about what you need to study for the final exam. It will be an in-class assignment. It will be different. This is the software engineering course. It's going to be different than the weekend one. If you've noticed, I've got the study guide for the weekend course. If you want to take the weekend course, final exam is being offered this Saturday. And there should be a lot of openings because half that class doesn't want to take it. They all want to take it in August. But here's the thing, the one that's going on Saturday is open book, open notes. It's because it's so soon for that class. It's going to be a completely different exam than the one you're going to take. On the same subject matters though, but it'll be a different exam. But if you're overly optimistic and you think you can pass it right now and you can print out some notes and stuff, you can take it this weekend on Saturday if you want. You guys can take it this weekend. Open book, open notes. That's the review. It's in that document. It's I don't know if I've got internet access right now, but in the it's supposed to be down right now actually. No, it's down. Yeah, the internet's down. But if you go into the bhacker.com, you go into software engineering, you can see the review document for the weekend section. That class is having their final exam this coming up Saturday on the 16th. From 9 o'clock in the morning till 4 o'clock in the afternoon. You can come in, you can take it. Oh, I'm going to have half of that class show up, though. They don't want to take it. If I were taking it, I think I'd want the open book, open notes. But it's early. I mean, again, it's 2 weeks early, and there's no final exam review for it. Instead, I did list out, and there's 6 questions on it. There's 6 essay questions. And they're not really essays, they're short answer questions. And I gave you the subject matter of the 6 questions. So you could study the answers to those 6 questions, come in with your notes, and ace the exam, essentially. I don't know, food for thought. Because I always open it up both ways. The weekend people can take the weekday exam, so why can't you guys take, and you can, but the only weekend class is the software engineering one. So anyway, think about it. If you're interested in doing it, show up this Saturday. And if you do show up this Saturday to take it, make sure you put on there, I'm in the weekday section, so I can find you on my roster correctly. So, questions? Comments, concerns? Nope, we're done for today. Show your lack of internet.